All right, we're continuing from the first function notation. So the f of negative 4, could we figure that out? And what did you guys come up with? What would I do, Chris? We substitute in negative 4 for x, and we get 2 times negative 4 is negative 8, plus 3 is negative 5. All right? Now, sometimes, notice, I don't have the function of x. I've got the g of x. And I'm doing that because now I have two different equations, right? Two different functions. So I have to differentiate between them. I'm going to call one the g function, and the other one is the h function. So you'll notice on number 1, with the g function, I'm going to go and use the g equation. So what they want me to do is use the domain of 4. So I'm going to do 2, you're writing this 2. 2 times 4. And the g of 4 is equal to what? 8. Okay? This time, I'm going to use the h of negative 2. Which function equation am I using? Gabby? The h1. So I'm using this. And so I'm substituting in, how's it going to read, Nicole? Plus 1. So I'm going to get negative 8 plus 1, and that equals negative 7. And the last time I've got to put this in, so I know that we're talking about the function of h, the h function of negative 2, the h of negative 2, with the domain of negative 2, is negative 7. Is this clear? Thumbs up if it's clear, thumbs down if it's not. All right. Let's move on. So there's a lot to go over. All right, notice these get more and more complex. So in number 5, which I don't even think they're going to give you tonight, but notice for the first part, I'm using the h equation. So I'm going to substitute in 3x minus 2. And I'm putting it in its own little parenthesis. And then I've got plus the g function, I'm using x squared. Now, what do I substitute in for the first one, Chris? 3 times 4 minus 2. And I'm keeping that in my little parentheses. And then I've got my plus, what am I substituting in for x squared, Saffron? Okay, Nicole, what am I substituting in for x squared? I'm substituting in that 1. It's telling me the domain, Saffron. Okay. Does that make sense? So in the blue one, I'm substituting in for the h equation. I'm substituting in right here that 4. Wants me to use that. Do you understand, Saffron? Okay. And then we would evaluate it down. So I get, that's 12, minus 2 is 10, plus 1, what does it equal? 11. Okay, questions? Okay, moving on. So this is an example of evaluating with something a little bit more complex. I don't think that the homework gets to that too much tonight. But this is what your homework will do. So when I have x is equal to negative 1, the first thing you need to do is you need to rewrite this function. The f of negative 1 equals 4 times negative 1. And then you evaluate it. What's the value of it? Negative 4. Okay? I'm going to do it that's the first domain. You with me, Saffron? The second time, it's asking me, they're giving me 3 different domains. Real pain in the butt. That's why usually I give you 20 to 30 problems. This is less, right? Half of 35 is like 16, 17. 17 and a half problems. 17. Okay. So now I have to use the second domain, and I'm doing the F of, what am I writing here, Zach Smith? For the second domain.
0.
The F of 0 equals, I got to use this equation, 4 times what? 4 times what? 0. So the F of 0, are you understanding that I'm using different domains, is 0. Does that make sense, guys? And what else do I have to do, Zach? Because I want to torture you guys tonight. So what am I doing for this one right here?
F of 2 equals 8.
F of 2 is equal to, I got to write the problem. 4 times 2. And so the F of 2 is equal to 8. Now pay close attention here. This is where kids get marked off. You can write your answers like this, right? In boxes and say the F of -1. Or you can put them into braces. But you must put the result of the first one first. You've got to put this first. Yes, in order that you get them. And what was the result from the second domain? It was a 0. And what was the result of the third domain? It was an 8. So you got to keep it in that order. You're not going from least to greatest. Because if you were to write this down, this tells me that the domain of 0, the second one listed, is 8. Do you understand? You have to keep your answers in the same order. A lot of kids lose points there. Okay? All right, can we move on? All right, next one. How would I write this into an equation? Write the function rule for this one. Let's get Caleb.
P of H is equal to...
P of H is the dependent.
Yes.
That's like our what? Our range or our y. So the P of H, he's right. The P of H equals 450, and we wouldn't use that x. What would we use?
Oh, H.
H times hours. So really it means my pay is equal to 450 per hour. How did I know to put the H? Because I saw it here. Clear? Okay, I'm going to jump to a little bit of the book work right now. So I want to go through some of those examples. So again, like here in the book, they're giving us how many different domains to try? How many different domains? Show me with your fingers. That's right. 2. So you have to do it each time you have to substitute in. One was 2, the other one was -2. Now, this is a book problem, and I thought when I first read it, I felt like it was very awkward for me. I didn't think it made sense. But the more that I do these, the easier I understand that book. So let's look. Let the F of T be the outside temperature. Let the F of T be the outside temperature in Fahrenheit. You with me? That's the first part. What does F of T stand for?
Outside temperature in Fahrenheit.
Outside temperature in Fahrenheit. And T, hours after 6 a.m. T is for hours after 6 a.m. So what does this really mean? So instead of the F of T, what are they writing? The F of 0. What does it mean? Chris?
Maybe it means that like 0 is outside after 6
No. Remember, the F of T is your Fahrenheit, not just the T. Yes.
0 degrees Fahrenheit?
Nope. Yes.
0 after 6 a.m.
Right. Remember, this is a T. So this really means 0 hours after 6 a.m. What does that mean?
58 Fahrenheit.
Right. Remember, the whole thing is the temperature. So 0 degrees after 0 hours after 6 a.m. is 58 degrees. What does this mean? What does the second one mean? Deja. What's the temperature? What's the temperature? Caleb.
Celsius?
No, they mentioned nothing about Celsius. We're not going to stuff that's not mentioned. Dariush. Yeah. The temperature is N degrees Fahrenheit. In this case, 6 hours after 6 a.m., the temperature is N degrees. What does this mean? Ian.
The temperature at 3 hours after 6 a.m. is less than the temperature 9 hours after 6 a.m.
Does that make sense?
Yeah.
What's 3 hours after 6 a.m.? 9. And like 9 hours is like 3 o'clock. Is it likely that 9 a.m. is going to be a lower temperature, cooler than at 3?
Yes.
Okay, so you're starting to understand this kind of language? So really remember, this is my domain, and my domain is T, and T is hours after 6 a.m. All they want you to do is make sense of this phrase. That's it. There's nothing to do with this. All right, here's something else you're going to see in your homework tonight. Now, for the h of x equals 2/3 x minus 5. Write this one down. Find the value of x for which the h of x equals -7. What do they want? What are they wanting? Nicole. Yeah, I have to find what x equals. I'm looking for my input. Okay, so how would I go about doing this? I've got the h of x equals 2/3 x minus 5. What do you think, Zach?
-7 equals 2/3 x minus 5.
Guys, look. H of x, that whole thing, that's really my fancy y, right? And this is the same thing as the h of x. So I'm just substituting, just like Zach said. -7 equals 2/3 x minus 5. What do you think we do next? I'm going to go with Saffron.
Add 5.
Good. We're back to our equation. So then I'm left with 2 equals 2/3 x. Next step. Ian?
It's -2.
Oh, -2. Sorry. Next step.
Multiply by 3.
Or
3/1.
how about 3/2? Because I can do this in 2 steps and I can clear the whole thing. I'm left with negative 3 equals x. So, actually, of most of the textbooks I've seen, this is the first time I'm having them have you search for your x, but there's a new standard in here, so we're going to need to be figuring out what our x is. I need to talk to you. Questions? All right, there's one more type of question that you will encounter, and this is it. Graphing. So, when it says graph the f of x, the only thing that's different, this is as good as graphing y equals 2x plus 5. What's the first step in graphing? Yeah.
Putting your y-intercept.
No, not yet. We're kind of here. Table.
Oh.
The hard man's method. Make a table. And look at how I'm labeling my table. I could do it horizontally. I can do x and the f of x. This is really the fancy way to write y. I'm calling it the f of x. And what did I say for the input? Where do we get those values? We choose. Choose some negatives. Choose some positives. Keep it close to 0. And so then, let's see. When x is negative 2, what is my y? It's 1. When x is negative 1, what's my y? When x is 0, good. When x is 1, and 9. And then we make our graph. Oh, that's bad. I'm making the graph. Make sure you are using a straight edge whenever you graph. I never want to see sloppy lines. Make sure they're arrows. Miss Cacciatore should have been insistent on that. Okay, and now I'm plotting my ordered pairs. Would this be discrete or continuous? Why is it continuous versus why is it discrete? Ian? Oh, sorry, Chris? Why is it discrete? Right, because what if I plugged in a half? Right? I want the pattern for all numbers on here. And that means includes my fractions. And remember, you're using a straight edge. It's really hard on a iPad. Make sure you have your arrows. And so here is my f of x equals 2x plus 5. So on these, when they just give us an f of x and it's not situational, you're going to make it continuous. Yes, Jairus. It's really loud right here. What? No, I want you working. This is huge in Common Core. The old standards, hold on. The old standards, we used to do y equals. We used to do linear the whole first semester, quadratic the second. These standards, we start with functions early and we compare them. We look at linear, we look at quadratic, we look at exponential.